I am posting a link. In the chat, I am posting a link to the Harvard Informatics GitHub page. If everyone could just follow that, then I'll share my screen and I'll show you what we're going to do next. Share screen. Informatics. Okay, so you should all be looking at a page that looks something like this. Once you're here, scroll down to what we're going to be doing this lesson in a Jupyter notebook, just because it's easiest. So go to this Intro to R section and click on the Launch Binder link. It'll take you to a page that looks like this. It might take a minute or two for it to start up, especially for the first time you launch the instance. So just give it a moment. And if you're having problems, just let me or Tim or Nathan know.
That's strange that it's rebuilding it for you.
I know, I'd run it just like 10 minutes ago.
Yeah, it just found it and launched it for me, so I'm not sure.
Yeah, sometimes it is temperamental in how long it takes. So when it works, you should see a RStudio page come up, which hopefully will take just another minute for me. Sometimes if it gets stuck like this, restarting it and relaunching it can sometimes help, but I'm going to be patient and wait another minute or two. Hopefully it runs.
For what it's worth, I just hit reload and it found the image and it launched it on a different Kubernetes cluster.
Okay, so just refreshing the page, do you think?
Yeah, maybe give that a try.
All right, let's see. I hope I just didn't reset all my progress.
You can check the build logs if you expand.
There we go. Good suggestion. Thanks, Nathan.
No problem.
Okay. So I'm going to assume that it's running for everyone. If not, you can try refreshing the page like I just did. You should see a interface that looks something like this. So if you haven't used it before, this is R Studio. It's a nice graphic user interface for running R. It's super handy. So there are a bunch of different panes here. This is the console. You can run commands at it. But what we're going to do is down here. So this is your environment, like where all your data files are. Go ahead and click on the index.r markdown file right here. You should get another pane that pops up that shows you the kind of layout for today's lesson. As Tim mentioned, so this is part of another workshop that we normally run that's like an all-day affair. So this might run a little longer than a normal coffee hour. It won't go all day though, don't worry, it's just like 40 minutes or so. And for this first lesson, I'm going to be taking you through just kind of the basics of R, its data structures, beginning to how to manipulate data, read, write files, that kind of thing. So first off, so we're working in this kind of pre-set up Python notebook. So, but normally when you're running this on your own, it's good to first just get an idea of what directory you are working in. So that will tell you like where you're going to be reading and writing your files to and from. And also to show you, in case you're not familiar with R Markdown here. So these little kind of like gray code blocks right here, these are commands that R Studio will run. You can run things in a few different ways. If you're on a code block, you can click this little play button here that will run everything in the current block. If you click on a certain line, you can then mouse over to here, hit run and do run selected line. And if you're on a Mac and just as a shortcut, you can select a line and hit Command Enter. They all do the same thing. So what this command is doing here is this is just showing you what directory we are currently working in. So it's just this home RStudio directory. That's actually what is displayed over in this panel right here. So this is a graphical representation of that. However, if you're working just at the command line, this might be useful. Okay, I'm going to start with just talking about one of the most basic data structures in R, which is a vector, which is a one-dimensional object. And it can contain a variety of different types of variables here. So in R, the way you define a vector is you give it a name. So we're going to call it V1. You then give it a little caret and a dash, so a little arrow to define it. You then type C, and then in parentheses, we'll just do a string of numbers, like 1, 2, 3, 4, 5. I'll go ahead and run this code block. You should see over here in the environment, so this is where it lists all the different objects you've created so far. We can see we have an object called V1, which is a string of numbers. So just as a note, you need this little C right here, where this stands for combine. So this is what makes it into a vector. If we want to display the contents of a vector, we can do print v1. Go ahead and run that. You can see it just spits out the content of the vector. As a note, you actually don't need this print and parentheses statement here. You can just type v1. So if you just go here, do v1, run that, it spits out the same thing. So let's go ahead and find a couple of other vectors here. You can make just a so it doesn't have to be a list of numbers. It could just be a single one. So we can call it x is equal to 10. Then just have it print out x. So if we run that, just prints it out. We'll make another one. Y is equal to 11. Print them both out. And then if we want, say, a string of different characters, we can make one called sum letters. C. And for characters, you need quotation marks around them. So do A, B, C, D. Print it out. So note that if we didn't include the little quotes around it, what R would do is this would look for a function or a variable called A, B, or C. So if we did try to define it like this, and try and run that, we should get an error message. See, so it's looking for an object called A, which doesn't exist. So just something to keep in mind. If you want to list out all of the variables that you've created so far, again, when you have the graphic user interface like this, it's not as useful, but if you're just working with command line R, it can be helpful. We can do this ls command for list. You can do that. You can see it prints out all the different objects we've created so far. One useful thing before going forward is getting help for R different functions in R. So the way you can do this is you add a question mark before the function you're running and then the name of it. So if we run that, you can see it'll open up in this panel here a little help page for it. This will tell you all the different arguments you can give to the different functions, what kind of function it is. If you're not exactly sure of what the name of the function you're trying to get is, you can search for it in help pages using two question marks. So we run this here. It'll search for it and it'll give you ones that match it over here. Okay, I'm going to click back over to the Files tab. Okay, so if we want to now begin to manipulate different objects, so R supports all just normal arithmetic on objects. So if you do x plus 5, for x is 10, it should print out. I'll just do it there. You can multiply things, x times 2. One thing to note is that the value of x is not modified here. It still stays as 10. We're just printing out the result of these calculations. If we wanted to actually change it, we have to update its value again using the assignment operator. So if we do x, then we do x plus 5, we want to print it. You can see now the value of x is properly updated. Just one other cool note is that R will do vector math for you automatically. So if you're trying to multiply two different vectors together here, so that the first one we created is v1 times x. Go ahead and run that. It'll multiply them all. And say we want to save it then as a separate vector. We'll just call it v2. This again, use the assignment operator, v1 times x. You can see it creates a separate vector here. That's the product of them. Okay, just to get you guys familiar with these, like actually running these commands, there's a couple of exercises throughout here. So for this first one, go ahead and try and create a new vector, call it nums, and just have it have any 5 numbers you want. And then so to introduce you to a couple of other functions that operate on vectors, such as the length, the max, the min, the mean, all the names are kind of self-explanatory. So once you've created nums, try running these functions on them. I'll just give you a minute or two and then I'll walk through them. And again, you'll be posting, you'll be writing it in this little code block right here and then running it. Okay, so this example hopefully was pretty straightforward here, but I'll just walk us through anyway. So if we do, we'll make our new object called nums. We'll make it just a list of numbers. So 33, 22, 41, 54, 91. So if we go ahead and run that, created it. And then to run the different functions on it, we can do length nums, and max nums, min nums, and then the mean. So if we go ahead and run this, so the length of it is 5 because there are 5 elements in the vector. The max is obviously 91, min is 92, and then the average of them. Okay? Okay. So we've been dealing with objects of 2 different types here. All objects have a type. At kind of the basic level, you can have an atomic vector, which is an object that only has a single type of data, such as all strings or all numbers, or one that can bind different atomic vectors in different ways, which we're going to talk about in a little bit when we talk about data frames. So first, looking at some of the objects we've already made here. If we want to look at what type of object it is, we can use this class function. So class nums, class some letters. So if we run that, we can see this is a numeric vector and a character vector, respectively, which makes sense. These are the 2 most common kinds of vectors. One other useful one is a logic vector. So this is, you can think of this, if you're familiar with other programming terms, like a Boolean, sort of. So it can only, a logical vector can only have values of true or false. So we can create one if we want, called logic1. You see, so then it could be true, true, oops. Let's do it in caps, true, true, false, false. Then if we go ahead and print out what the value of this vector is, oops. Am I? Did I make a typo somewhere? Logic 1. Oh. There we go. I just didn't have, I forgot to get rid of the parentheses there. You can see it prints out the value of it, which is it's true, true, false, and false. And we can also check the class of it just to be sure. 1. You can see it's a logical type vector. You can also, so making it manually like this isn't super useful. You can also use different logical tests to create a logical vector. So say we want to make one called logic2. And we want this to, so take our first numeric vector we made, v1, and so when each element is greater than 2. So if we go ahead and run this, actually, we'll print it out, logic2. So if we run this, we can see, so if we look at what is in our v1 vector, it's just 1, 2, 3, 4, 5. So for the first 2 elements in that vector, 1 and 2, they aren't greater than 2, so they print out as false, and the rest are obviously true. So you can, one thing to note is that this is not printing the values here, it's just printing whether it's true or false, because it's a logic vector. And so this test we did right here is applied to each element independently in the vector. This will be more useful when we talk about subsetting different types of data. So go ahead as an exercise for yourself, make a logical vector called big nums that is true if the element in the nums vector is less than the mean of the nums vector. So it'll look something sort of like this, except the syntax will obviously be different. So I'll go ahead and give you a minute or two to try that. Okay, so I'll walk us through it. So first we name our new logical vector big nums. Here we then have the logical test. So we want nums, and we want it anything that is greater than the mean of nums to evaluate to true. And I'll just print out the value of it. So if we run this here, we can see, so we created the big nums. So the first three are false and the second two are true, which kind of makes sense. Okay? All right, so the reason I bring up logical vectors here is for their use in subsetting vectors. So previously we've just been printing out the entirety of a vector here, but say we just want a specific element or range of elements within the vector. You can specify these in a number of different ways. You can do it, the position is referred to with this, these square brackets right here. So you just give it the number of the element in the vector. So say we just want the first element. So we could do nums1. You can see, so looking over here, the first element is 33, so that's correct. It's just spitting out the first one. You can give a range of elements in the vector using the colon. So nums, say we want 1 through 5, we do 1 colon 5. Go ahead and run that. It spits out, so it's spitting out all of them. We can do a specific subset of them using the combine function as before. So nums bracket, so C parentheses, say we want the first, fourth, and fifth. Go ahead and just run all these. You can, it's just taking the 1, 4, and 5. So you can specify them manually like this. However, it can be easier to subset them using some type of logical rule. And this is mostly where you'll be using logical vectors. So we just created a logical vector called big nums that was the same length as our nums vector. And it was true when the mean was greater than the, or when the element was greater than the mean of nums. So just to refresh on that, we'll do nums and big nums just to print out what they look like here. So say we now want to extract all the values that have, or the elements that are bigger than the mean. So we can do this just by putting it in brackets here. So we can do nums, square brackets, big nums. If we run this, you can see it is just pulling out the last two elements in the nums from the nums vector, which are these two, which are the only ones that are true. You don't actually have to define this logical vector ahead of time. You can just do it when you're subsetting the vector, like so. You just have to define the logical rule within the square brackets. So if we do nums square brackets, we want nums elements that are greater than the mean of nums. We go ahead and run that. We get the same thing. So which of these you prefer, whichever makes more sense to you. All right, we'll have just a quick practice here. So using the same nums vector that we've been using, subset all numbers that are larger than the minimum of nums. So you can do that in either way, by defining a different logical vector or just doing it, defining it within the subset command. So go ahead and take a minute to do that. Okay, so I'll walk us through it here. I'm just gonna do it all in one command. So if we just do nums bracket nums greater than the minimum of nums, go ahead and run that. You can see it spits out everything except for the minimum value. Okay. So we're going to switch gears and talk about a different type of data structure in R now. So far we've just been talking about atomic vectors, which are only a single data type. And you can also, and it's also just one dimensional. You can have higher dimensional types of data structures in R. And this can get a little complicated here. This is just a table that kind of shows you this. So a one-dimensional data structure of a single type is an atomic vector. We're going to be talking about data frames. Matrices and lists are kind of their own thing. Tibbles are a special type of data frame that for the subsequent lessons next week and afterwards, when we talk more about tidyverse, we'll be getting into. At the moment, we're just going to focus on data frames. So these are two-dimensional structures that can have a mix of different data types. So let's just create one right here using the data.frame function, just as a little example. So let's call it df1, defining it. So do data.frame. We're then going to have a list of different atomic vectors that will make up the data frame. So we're going to call the first one label, and we'll set it equal. This will be a string. So we'll do just say rep1, rep2, rep3, rep4. Then we'll have another one called data. This will be a numeric one. So we'll do C, let's say 23, 34, 15, 19. So one thing to note is that while you can have different types of atomic vectors in your data frame, they do have to be of the same length. So these are both length 4. Let's go ahead and print it out. df1, class as well, for the sake of it. So you can see over here in our environment window, we've created the object right here. Its class is data.frame. We click on this. You can see this is what it looks like. So it's kind of like a 2-column list, basically. Well, I shouldn't say list because that's a type of object. So it's a 2-column spreadsheet. One function that can give you information about the different parts of a data frame is this str. So if we do str df1, we run that. It's a data frame of length 4 with 2 different variables, so label and data. If you just want to look at a part of the data frame, just the first couple of lines, you can use the head function. So this will be more useful with a larger data frame. You can specify how many lines you want. By default, it will print out the first 6. So if we do head df1, go ahead and run that. It prints out, so there aren't 6 lines in this, so it just prints all of them. Say if we just wanted the first 2, we could do head df1, then n equals 2. Go ahead and run that. Just prints out the first 2 lines, not counting the names up here. And also the summary function can give you kind of a snapshot of all the different data in your data frame. So we do summary df1. Go ahead and run that. It gives you some like statistical data here. So that can be useful if you have like numeric values. Okay. So we just kind of manually created a little toy data frame. That's usually not what you're going to be using it for. Normally you're going to be reading in data frames. It's like the output from your experiments or whatever. And so you'll be reading it in from an external file. There's a few functions that you can use in R to do this. I'm going to talk about the read.table function here. So I'm going to create a new data frame called bus. I'm going to do read.table. And again, remember, if you're not sure of what arguments a function takes, you can always do the question mark before the name of the function to get it. We're then going to give it the path to the file. So again, if you are doing this on locally on your own desktop, you would have to give it the full file path. We're in this kind of preset up environment. So it is in this data folder right here. So I'll give it the whole path anyway. So I'll do home/rstudio/data. So this is just some data from the MBTA about the bus. So data bus.tsv. We then need to specify what separates the different values. In this case, it's a tab separated file, so TSV. So we do sep equals T, the \T for tab. And we need to tell it whether the first line of the data of the file we're reading in is the names for the different columns or not. In this case, it is. So we do header equals true. We can go ahead and, well, also I'll do print out of it right here. So we go ahead and run this. So we can see we've created the data frame called bus right here. And it is just printing out the first couple of lines of it, right? Well, it does actually print out the entire thing. I should have used the head command there. You can see, so it is a several column list with different information about like the ridership, what type of bus it is, etc. Okay, so actually, well, I guess here's why I didn't do it. So use the head command to look at just the first 20 rows of the data and this summary to get some information about it. So this should be pretty quick to do. So we'll just do head, bus, summary, bus. Okay, so this is like the first 6 lines of it. Oh, it's supposed to be 20. Whoops. This. You can see it prints out the first 20 lines. Then some summary statistics for each of the different columns. So you can, when you're in RStudio, sometimes I find it helpful, you can use the view function here. So if we do view bus, what this will do is this will open a, oh, it's a capital V. I always mix that up. View. This will open a different tab up here. So if you, this kind of helps you visualize it like an Excel spreadsheet, which can be useful. You can't modify it at all, but if you just want to like look through your data, spot check it, see if anything seems off, it's very useful. You can also click on it in this panel over here to do the same thing. Okay, I'm going to talk quickly about subsetting and manipulating data frames. So we previously subsetted atomic vectors. So to get information out of a 2-dimensional data structure, we have to specify the row and column. So again, we're going to use these square brackets here. But you have to specify which row and which column you're pulling out. So say we want the first element of the first row and the first column, we would do bus square brackets 1, 1. So the first number is the row, the second is the column. Run that. You can see it spits it out right here. Don't worry about this second line. This is just showing all the different possible options that are in that column. If we just want the entirety of the first row, we can do bus 1, and leave the second one blank. We run that. It just spits out the entire first row. You can do a range. So you can do, say, if you want the first 5 rows, you can do bus 1, 5, just as before. He spits out the first 5. If you want then a specific, so we can do bus 1, 5, then 4. So this just spits out the value in the 4th column for the first 5 rows. And then finally, you can also give it a list of vectors to pull out. So bus, you can do C 1, 3, 5, comma C 2 and 3. So the second and third columns are the first, third, and 5th rows. So you can play around with this as much as you want. However, if you want to, sorry, I think I skipped over something here. If you want more than one column when you're extracting it, just note that it will extract it as a data frame. Otherwise, it'll just return it as a vector. So sorry, I just lost my place here. Actually, I might skip this just for time. So this is if you want to manually pull out different rows or columns. If you want to do it matching some kind of criteria, we can use this subset function. We're going to talk a lot more about pulling stuff and manipulating data frames when we talk about tidyverse. But say we just want to get the data for only the key bus routes here. What we can do here is we're going to create first a new data frame called key.bus. Do subset. So then the data frame that we are subsetting, the bus, we are then, so it might be helpful to first view the bus data frame here. So we want everything that has in the second column a value of key. So this column is called type. So we're going to do type double equals. So that's equal to key. So if we go ahead and run this to view, but key.bus. So we go ahead and run that. You can see we have subset it, so it's only things that have key here. Okay, you can do a little more complicated logical operators on it here. So say we want all the local buses that have at least 1,000 daily riders on this. So the way you do this is you link your conditions with an ampersand sign. So let's make another data frame called local.bus. You're gonna subset it, bus. Type equal to local. Then we do the single ampersand, and ridership is greater than 1,000. Say view. So if we go ahead and run this, oh, I just made a typo. Ridership. Okay, so you can see it uses both of these conditions here. For the interest of time, maybe I'll just walk you through these different examples here. So say for the first one, well, this is kind of a similar one. So we can do subset bus ridership greater than 2,500. Oops. See there. For not equals, we do the exclamation mark equal sign. So subset bus type does not equal key. And run that. It gets everything but where this is true. And then if we want to combine these into a different data frame, so let's just call it bus 2,500, not key. Just combine them, subset bus ridership greater than 2,500, and type not equals key. Let's run that. Okay, we made our, you can view our data frame. Looks good. I always find it helpful to just like double check it. Okay. Yeah, so we're going to talk a lot more about manipulating data frames and also tibbles when we talk about tidyverse. But just for the last thing I want to touch on is writing data. So normally you need to output your data in some type of form. So just as there is a read table function, there's also a write table function. So similarly, write table, you give it the data frame that you want to output. So say we want to output bus, we give it a name. I'm just going to output it to the directory I'm currently in. So if I don't specify the full path, it will put it in my present working directory. I'll just call it mbta plus data 2.tsv. There's a bunch of different arguments you can add to it. So by default, it will output it with quotes around each value, which is kind of annoying if you're trying to parse the data later. So we can do quote equals false, step equals tab. We're going to tell it to not output row names, but we do want column names. And again, remember, if you forget what these arguments are, you can always just search the function and it will tell you all your different options. So we go ahead and run this. You can see over in our little environment pane over here, we have this new data that we outputted. So again, this will be more of a issue when you're doing it on your own computer. Just be sure to specify the full path. I had you do an exercise here, writing it with a different name, but I don't think that's super necessary. The instructor copy of this lesson is available right here as well as on our GitHub page. Um, I think that's mostly everything for today. Hopefully we'll see you all back in the subsequent weeks or when we talk about Tidyverse. And let me know if you have any questions. And if not, feel free to head out. Thanks for stopping by. We'll stick around in this call for a while in case anyone has any questions.